Hello everyone. In this second video on parcellation, I want to show you two little things which will hopefully make your scripts a bit better and will help you um, to control your parcellation a bit better. This is the result of the first video on parcellation 1. And if you don't know what I'm showing here, then please watch the first video first. And the things I want to show you here is to ensure that all parcels actually have some access to the road, some direct access to the road. And the second part is how to control the size of parcels based on distance to attractors. Like how can I make parcels wider or more narrow based on distance of each particular city block to some point attractor or maybe line attractor. So I'll cover those two things. I hope to do it pretty quickly. I will maybe skip some things, but hopefully you can understand how these things work. So first point, how can I ensure that all parcels have access to the streets? Well, the easy reply is that we somehow need to ensure that there are no parcels which are situated right in the center of the city block without any access to one of the streets. And we can do it by simply always having only 2 rows of parcels, not 3, 4 or more, but let's cap it to 2. And if you go to the divide the main component, which has 2 inputs called U and V, which define the number of segments in U and V direction, you can probably remember that we currently compute those U and V number of segments by dividing the original segment dimension of the bounding box for each of the city blocks by the number which is the desired size, the desired depth and desired width of the parcel. And therefore we come to the number of segments we want to do. So basically the whole idea is to cap this number with an integer 2, right? So if the subdivision implies that we will have 3 or 4 or more rows, we want to lower it to 2. And we can do it using the minimum component. So I'll make a bit of space for it and create a new minimum component. It takes 2 numbers and simply returns the one which is the smallest of them. So I want to put this nearest number from the round component there, and I'll create a new panel with the number 2 for the second input to the minimum. And now watch what happens when I put it here in the U, back in the U input of divide domain instead of the original round. You can see now that all parcels which originally were divided in 3 or maybe 4 rows are now divided in only 2 rows. And actually it will happen no matter which number we put here. So even if you put the very low number like 30 meters, this is, by the way, parcel depth in meters. And this is parcel width, also in meters. Okay, so yeah, even if you define the parcel depth to 30 meters, we will still get at most 2 rows of parcels. So without this minimum, this would look like this. And of course, that's not something you want to have for your parcellation. Okay. Oh yeah, one important thing is that I'll make it 150 back again. One important thing is that even though we use this minimum of 2 and the computed number, there is a more easy way to do it, right? We can simply use 2 without any minimum and without any numbers. But the drawback of this method is that some parcels, some city blocks, as they become smaller, they do not always need to be divided into rows. And in this case, if we just hard code 2 here, it will get a bit tricky in these cases like this one, right? Because basically, based on our algorithm now, when we do not use minimum and round and division, we will always have this division in 2. And so the parcels get really small. And so the advantage of this approach I'm showing to you here is that sometimes parcels, so if the city block is not deep enough for 2 rows of parcels, the second one will be omitted and we will only have 1 row of parcels. Okay, and the second part is how to control size of parcels. By size, I mean parcel width in this case, based on the distance to some attractor. The idea here is to compute the distance from each city block to some point, which I will call attractor, and then convert those distances to parcel width. So if the distance is really small, meaning that the parcel is very close to this attractor, I want my parcel width to be minimal, like I want it to be, I don't know, 10 or 20 meters. If my city block is really far away from the attractor and the distance is very large, then I want it to be converted to some higher number, like 200 meters. Let me do it. So it basically implies that I have 2 steps here. First of all, I compute the distance from each city block to the attractor, and then I somehow convert this distance into the parcel width. So 2 important components I will use here are called curve closest point and remap numbers. And they basically serve these 2 functions I was talking about. Curve closest point will help me to find the distance between all of my city blocks, so I can connect city blocks to the C input of curve closest point, and attractor, a point. So I have to define this point somewhere. I will jump back to Rhino and create a new point here, and just put it somewhere here. Now I also need to reference it in Grasshopper, so I need to create a new point in Grasshopper, right-click it, set 1 point, and select my point. I can also give it a name, not to forget about what it is. Now I have some distances, right? This is a list of numbers, so it represents the distances from each city block to this attractor point. Now let me talk a little bit about the remap numbers component. It has those 3 inputs: v, value, s, source domain, and t, target domain. As you know, domain is just some range of numbers. So in this case, they are predefined as 0 to 1, and value is just some value on this domain. Remap numbers allows you to take the source domain. This is source domain. Take some value on this source domain, right? So let's just assume the source domain goes from 0 to 1. Of course, it shouldn't be the case. It can go from any number to any other number. So this will take the v point on the source domain, and it will try to, and this is the target domain, and it will try to find the point on the target domain such that it breaks the target domain in the same proportions as v breaks the source domain. So basically, you can make these lines here, and you will see how, I'm It's not that clear now on this drawing of mine, but it will always try to find, for any v on the source domain, it will try to find the corresponding place on the target domain. It will function somehow like this. And it will help me to convert distances, so some values which indicate the distance from city blocks to the attractor point, into the parcel width, right? So it will try to keep all the proportions the same. So if city block is close to attractor, the parcel width should also be very small. If the distance is very high, then the parcel width should also get higher. So this is the whole idea behind this remap numbers and why I'm using it here. So my source domain here is the range of all these distances, and my target domain will be the range of my parcel width, which I want to get. Okay, I need to start by entering my parcel width domain, and I will enter it using the panel, and I will use something like 50 to 150. So 50 meters to 150 meters. And this is my parcel width domain in meters again. So this is my target domain. I can connect it to the T input of remap numbers. My source domain goes from the smallest distance to the highest distance between all my city blocks and the attractor point. So let's see. The smallest distance seems to be 147, and the highest seems to be 1178. Of course, I don't want to enter those values manually, so I will create the component which is called bounds, which does it for me. It will just try to find the minimum and maximum number in a list, and it will create the range from the minimum number to the maximum. And you can see how it works here. So it indeed picked the smallest number, 147, and the highest number, 1178, and created the domain for it. So this is my source domain. I can immediately connect to the S input. And now I need only to connect my values here. And the values are my distances, of course. So I want to convert those numbers into parcel width. So I connect my distances to the V input of remap numbers. I can also make it look a bit prettier, like this. And now let us check what are the outputs. And also I will probably restore the panel with all of my original distances. So as you see, my parcel width domain goes from 50 to 150. And if my original distance from city block to the attractor was 500, which is somewhere in the middle of this domain, right? So 500 on the domain from 140 to 1100, it is somewhere in the middle. It means that my parcel width will also be somewhere in the middle of this target domain from 50 to 150, so it's 86. If my distance is very small, like this number 8, 147, it means that my parcel size will also be very small, meaning 50, because small in my domain means 50. And if my distance was high, like 1100s, then I have 150 as my parcel size. And now I can directly use those numbers here instead of the parcel width. Why I can do it? Well, because my division component takes the values of dimensions, and dimensions are computed from the bounding boxes. So I have those, how many? 18 from 0 to 13 bounding boxes. Here they are. I compute 14 of their v dimensions. Think of them as y dimensions. U and v are just other names for x and y. And now I divide this number, these 14 numbers, by some number. But since these 14 numbers are all stored in data tree, this will also work for list in this case, but data tree is even better. It means that this 14 division, the division will be applied 14 times to these 14 different numbers. And I can use 14 different numbers in the B input as well. Of course, I just need to be careful with the data tree structure, because currently remap numbers gives me the list of numbers, and division already has the data tree as the first input. So the second input should be data tree as well. I can say that it is a data tree by looking at this wire, by the way. And if you don't see, if all of your wires look the same, it probably means that in your Grasshopper, you do not have this thing turned on, draw fancy wires. So if all wires look the same for you, then please go into display, draw fancy wires, and turn it on so that you'll now be able to really quickly say whether your data is data tree or data list or just a single item. So coming back to our business, I need to craft the result of remap numbers to convert it to the data tree. And now you can see that I have 14 numbers, each isolated in its own branch. And now I can connect it to the division, to the second division, instead of the B input. Let us check the results. Oh yeah, this was exactly what I wanted to show you. So now as I move my point, you see how size of parcellation also changes. And the city blocks which are closer to my point get larger, smaller parcellation, smaller parcel size, and the further my city blocks are, the larger parcels they become. And of course I can control it very easily now by changing this domain. So if I move it, if I make it from 20 to 150, you will immediately see how it changes. And if I make it 20 to 50, I hope my Grasshopper doesn't crash, but yeah, this is the result. So you can really easily change your parcellation now. I'll probably make it back to something like 40 to 160. Yeah, this is it. I think this is all. These were two things I wanted to show you. I will maybe just make my script look a bit nicer, turn off some previews I don't need. Oh yeah, and also I wanted to show how to draw a tractor in Rhino in a nice way. There is a small component which is called dot display. This one with the red dots here. It takes 3 inputs and it basically serves to display some points in Rhino. So you can connect your attractor to the P input, to the point. As the color, I will connect the color swatch there and give it some nice blue color. And the third input is called size. And I will enter something like 50. I think this would work. Or maybe 30. Okay, so these are my inputs to the dot display. And yeah, now I have pretty nice preview in Rhino. And I think this is all to this video. I will post some more videos. The next one will be on the placement of buildings on parcels. So stay tuned. I will be using parts of this script there as well. So yeah, I think the next video will be very easy for you if you understand what happens here. Okay, thank you for watching and see you in next videos.